Hi class, welcome to our Grad Stats Lab series in Lab 3 in SPSS working with correlation and simple regression. And our purpose here is preparing for conducting and interpreting regressions, which requires understanding the basis of general linear modeling, specifically that regressions are based in correlation, and those assumptions that are important for correlations carry over as we evaluate our first simple or bivariate regression, which is when we have one predictor, one outcome. The materials you'll need for this lab include the dataset, which is a DAT, a tab delimited file that we're going to work with. I made a Lab 3 lab sheet for us in SPSS, and the starter tables Excel. And these are linked in description and also available in our e-learning. So download those and we will get started. Okay, so I'm starting with our lab sheet here, and it's got our materials needed, and a regression is fitting these types of research questions. Like if we were asking, does one's perceptions of control, like internal locus of control, external locus of control, does this perception of internal control predict someone's experience of perceived stress? And this would be along the lines of a research question that fits a regression. The hypothesis statement would be something like, we hypothesize that perceptions of internal control will be a negative significant predictor of total perceived stress. And the study variables we're looking at are these, perception of control, perceived stress, and also we're going to build a correlation table with some more variables from this data set. Our tasks for Lab 3 are going to run like this. We're going to do some assumption checks, univariate normality and bivariate linearity. We'll conduct the linear regression of total perceived stress predicted by perceptions of control. We'll look up how this is written up, and we're going to create a correlation matrix to summarize the continuous information, the summary statistics about their relationships between study variables, so all of those variables. And where does correlation fit in here? When we are checking out bivariate linearity, we're running a correlation along the way. So correlation is a step towards conducting a regression when we're looking at continuous variables. So let's get started here. We need to read in the data, and this time our file is called tab delimited. This will be anytime you see an extension of DAT. And a tab delimited format is sometimes helpful when there is a comma in the data, because a comma separated values is going to get tripped up if there's actually a comma in the data file itself. So it's good to know how to also read in other types of data formats. So to read in our tab delimited file, we're going to open SPSS and do select import data text data. Going to SPSS, we have file, import data, text data. Here you navigate to wherever you put the DAT file, the survey.dat that you downloaded. And this is going to give us a little dialog box. It's loading up, and your text import wizard. Here, all of this is fine. We can see that it's starting to figure out the variable names and the columns of variable data. I'll hit continue here. How are variables arranged? Delimited by a specific character like a comma or a tab? Yes, we are delimited by tab in this file. Are variable names at the top of your file? Yes, they are. And a decimal symbol is a period, because different countries use a comma or a period for a decimal symbol. The first case of data, like not a variable name, starts on row 2. Each line represents a case, and we want all of the cases. So we'll hit continue here. Here, which delimiters appear between the variables? A tab does. Sometimes we do have data that is separated by a space or some other character, but for a tab delimited file, our data are separated by tabs. So we can continue here. Here it gives you a chance to go ahead and set the type of measurement for each variable. Like we know that the variable ID is going to be a string variable, so we can go ahead and tell it that. But you don't have to. You can leave it as automatic and fix that in the data file once it imports. And we've got everything ready. It's saying, do you want to save this file format? No, I usually just check out the import when I do it each time. So we're done. And here is our output window of it bringing in that data file. And if I go over to the data set, we see that it took my information about that this is a string variable and it set it up as a nominal variable. Good. If you did automatic, you would just need to change that to nominal there. The rest should be scale, and we need to go ahead and put in our labels. This one was positive affect. Cool. So once we have all of that, we want to go ahead and save this so that we don't lose track of it. You can give it whatever name makes sense to you. Lab3 survey.save. It'll be, because we're saving as a SPSS data file, it'll be a .sav. Cool. Now we're ready to start working with this. We changed variable ID to nominal. We made sure all the other variables are set to scale, added labels. We're not worrying about the categorical variables. I didn't even include them in this file because we're only working with the continuous variables in Lab3, and we've saved the data set. And with our assumption checks, we start by visually inspecting for whichever thing we're looking at, whether it's univariate normality or bivariate linearity, and then we follow it up with a test to see if our visual inspection is also lining up with a test of it. And again, we just report what we find. So to inspect normality, we're going to use Explore. To get to Explore, we go to Analyze, Descriptive Statistics, Explore. Here we're going to put our variables into the dependent list. We don't need ID, so taking off that one. And then in the plots area, we're going to turn on histogram, turn off stem and leaf, and also check normality plots with tests. And continue, and here we're going to paste. Now we can see what the syntax is doing. I'll leave myself a note. And running this syntax, we start getting the information about these continuous variables. So looking at positive affect and the normality test for positive affect. So all of the variables are violating normality according to the test. But looking at the histogram, we can see a little bit of negative skew, not much, on positive affect. And here's the box plot where we can see a little bit of outliers in that lower register of the scale. Negative affect with a very strong positive skew going on. And again, we can see that in the box plot with all of the outliers over on the high end of the register of the scale. Live sat is kind of peaky. It's trying to be normal. And total perceived stress looks pretty normal. So these are your visual inspection of the histograms and the box plots. Perceived internal control looks like it's got this set of outliers in the lower register. Yep. And following up that evaluation of the histograms is looking again at those normality tests, which are right there in the little table underneath that detailed long one. So this is the information we would want to look at when we're looking at univariate normality of the variables. For bivariate linearity, we're going to evaluate the scatter plot. And to get our scatter plot, we'll go to Graphs, Chart Builder, and choose Scatter. And the simple scatter plot is all we need here. We're going to put total perceived stress on the y-axis and total perceived control of internal states on the x-axis. And when we have that, we can hit OK. Looking at our scatter plot here, we're evaluating, is there some trend in the data? Do we see a negative flow of the data or a positive slope to the data? What are we picking up visually when we look at the scatter plot? We can also do some edits in here, either edits to the titles or the axes, but also when we click into this, we can add other information. Like if we see some outliers we want to point out, we can take the data labeler, data label mode, and label any that we feel are kind of far out. We can also add a line of fit. So right here, if I hover over that one, add a fit line at total. So I'm going to choose that one. And in the properties, I'm going to turn off attach label the line because it pretty much gets in the way. But it's on a linear fit method, putting a line through the best fit between those data points. I'll apply that and close the properties box. And I can close the chart editor. And now I have a fit line going through this as well. Makes it a little easier to see the trend in the data sometimes. Now the way we test the bivariate linearity is with a correlation test. And to do this, we're going to analyze, correlate bivariate. Here we want total perceived stress and total perception of internal states. So we're looking at the correlation test between these two. In options, let's see if we need anything there. Nope, not yet. Later when we make the table. And this is ready to paste. Looking at our syntax, we have that we're calling the function correlations between the variables total stress and total perceived control of internal states. It's a two-tailed test. If one value is missing for the pairwise, if one value is missing, then it can't run the test. So it's going to not run that pair if you have a case missing total perceived control it's going to not run that particular case because it needs both of them to run it. So running this guy, we have our correlation information. And looking over here, there's certain information that we want to pull out of this, both to understand the correlation between these two variables and also be able to write it up later on. So the correlation between these two is negative 0.581, which is along the lines of a negative significant correlation, right? We have negative 0.581 is the correlation coefficient. The significance, the p-value, is less than 0.001, which is a significant test. And it tells us that there were 426 participants who had values on both internal control and total stress. And these are just repeated across. So you don't have to worry about both sides because it's just a repeat of the information. So this is the information we need. The direction of the relationship is negative. The strength of the relationship is pretty strong. Our cutoffs are 0.1 is weak, 0.3 is moderate, 0.5 is where it's strong, and 0.8 is like very strong. So this is a pretty solid correlation here between these two variables. So that strength of relationship is a strong relationship. And then we're going to want the effect size, so the coefficient of determination. And we get that by squaring the coefficient. So we just take a calculator, 0.581 times 0.581. I didn't have to put the negative in because a negative times a negative is a positive anyway. So 0.3375, well, 338. That is our coefficient of determination, or our R-squared effect size for this correlation. And if I convert that to a percent, it falls right along 33.7, 33.8% of the variation in perceived control is shared with total perceived stress. Alrighty, so we've checked out the assumptions, both univariate normality and bivariate linearity. So now we're ready to run the linear regression between these two. Now, to conduct a linear regression in SPSS, we go to Analyze, Regression, and Linear. And here we want the outcome, stress, in the dependent box. And we want the predictor, perceived control, in the independent box. In the statistics area, we want some things. We want the confidence intervals for the regression coefficients. And then we're going to continue and paste. So we can take a look at this in our syntax. So regression is the call. It leaves out cases that don't have the data to support the analysis. We're asking for the coefficients of the regression coefficient, the confidence interval, the effect size of R, and R squared. And it's running, it ends up being an ANOVA test, an F test. And our dependent variable is total stress, and the predictor variable is total perceived control. So running this guy, now we have some information. So what are all these tables telling us about this regression? We have the ANOVA test, which this is where we would first look to say, is the model significant or not? So we're not talking about variables now, we're talking about the model, the regression model. The model is significant, and the test itself is an F test with the degrees of freedom of 1 in 424. So we know when we're reporting to a reader, we would tell the reader what kind of test, this is an F test, the estimate of the F test, which is 215.58, the significance level of that test. In an F test, we also give the degrees of freedom, and we tell the reader the effect size. So the effect size is the R squared 337. And in the details, so that's the whole model, that's the results of that whole regression model, is the ANOVA table. When we get into the details, we're saying what was the impact of total perceived control of internal states. This unstandardized coefficient is what tells us the amount of change expected in the outcome, so stress, based on the predictor, perceived control. So for every 1 unit increase in perceived control, we're expecting stress to reduce by 0.283. So the negative says it's going to go down 0.283 in stress for every 1 unit increase in total perceived control. So that's important. We want both of those, the constant and the predictor's unstandardized coefficient, the regression weight there. We see over here in the significance column that it is a significant predictor at p less than 0.001. And this is our confidence interval for the unstandardized coefficient. So the model estimated that the amount of impact of perceived control of internal states was negative 0.283, but it could have been anywhere between negative 321 and negative 246. Typically, as long as your confidence interval doesn't have 0 in the middle, like these two negative numbers means it's all to the left of 0. But if you had a 0 within the middle, it would not be a significant predictor because it could have been nothing. There could have been 0 impact of that predictor. This one is a significant predictor that perceived control does have an impact or predictive impact on total perceived stress. So that's the information we need out of here for the write-up itself. And there's still a missing piece here. We want the confidence interval of R squared. And getting that, SPSS doesn't give it to us, so we're going to need to go to a alternative source to be able to get that confidence interval of the effect size. So to do that, in your lab sheet, there's this website, Daniel Soper. And when we go there, we get to this. So you want to scroll down to regression. So it's in alphabetical order. You got to go down, down, down till you get to regression. And expanding that, we want to go down to R square confidence interval calculator. And that's what we'll use to get the confidence interval for the R squared. Here we fill out the information. We have one predictor, which is the total perceived control of internal states. Our observed R squared was, in our output, R squared 337. So that's what's going to go right there. And then sample size, we can get that from, we had it before when it said that there were only 426 that had information on both TP stress and TP coas, 426. So we can put that right there. And calculate. Here's our 95% confidence interval right here in the middle. So I can copy those numbers, I can transfer them to my write-up, but it's not in the right format we need for write-up, but those are the numbers we want. The R squared could have been anywhere between 264 and 410 if I go to 3 places. So that was 426. So let's check out the write-up. All of the information was 426. All of the information in our output can be used to fill in the write-up. We have letting the reader know about what the data set was about, and when we build our table 1, which is descriptives and correlations between all the study variables, we would let the reader know where to find that. Prior to analysis, data were evaluated for assumptions of univariate normality and bivariate linearity. We let the reader know how we evaluated normality. We inspected histograms, and we also ran Shapiro-Wilks normality test. Again, you can use your own visual inspection. Like maybe I think it looks normal, but you think it's like, no, that's not a normal curve. That's fine. Put what you think about that histogram in your write-up. I put that I felt total perception of control had a negative skew with several outliers, and that was confirmed by a significant Shapiro-Wilks test. Bivariate linearity was evaluated visually with the scatter plot, and then the data indicated a negative linear relationship, and this was confirmed with the correlation test. For the correlation test, I let the reader know what the test was and what the estimate of the correlation test was, what the significance level of the test was, and the effect size, the R squared. And then we finally get into the model testing. We conducted a bivariate regression to evaluate the research hypothesis of if total perceived stress could be predicted from one's perceptions of internal control. Results indicated a significant model. And here's all that stats line information, right? The F test was what was used. The degrees of freedom are 1 and 424, and that's in our, I give it to you here too. Right here in the output, 1 and 424, the value of the F test was 215.58, and the effect size. So we have the test, the degrees of freedom, the estimate of the F test, the significance value of the ANOVA test, the effect size, R squared, and the 95% confidence interval of R squared, and that's what we got from that Daniel Soper website. We have a way of interpreting the information that 33.7%, which is making a percent out of this R squared effect size, 33.7% of the variation in the outcome, perceived stress, was explained by the regression model. In specifically, perception of control was a significant predictor. So now we're down to that coefficients information. And the unstandardized regression coefficient, negative 0.28, the significance value of that coefficient. Beta is a standardized effect size, so the effect size for this regression coefficient is beta negative 0.58, and that's the standardized regression coefficient, whereas B is the unstandardized. The 95% confidence interval of the unstandardized is negative 0.32 to negative 0.25. And this information was all in that coefficients table. So the negative 283, the beta, the significance of that predictor, and the confidence interval. So the hypothesis was supported such that each 1 point increase in the predictor predicted a 0.28 decrease in total perception of stress. Now this prediction equation, we get this by indicating the constant 4392 and the regression weight for perception of control. So that 4392 was right here. So you need it for writing your regression equation. There we go. So that's writing up your regression analysis results. The last thing we wanted to do was build a correlation table. So to build a correlation table, we're going to run correlations between all of those study variables at the same time. We'll go to Analyze, Correlate, Bivariate, and instead of just these two, we're going to add everyone else. And I'm going to go ahead and make sure they're in the same order as my table so that my data comes out in an order that I know I have my table set up as. So let's take a look at that starter tables Excel. So in your starter tables, you have a bunch of tabs down here. And the first tab is just descriptive, so a table that has a place for means and standard deviations. That one isn't big enough for our correlation. You want to go over to the tab that says Table Core, and this has other variables, but that's okay. We just have to fill all this in. So I can delete that information, and I'll need to change that information. So you'll need to make changes to this according to the information that you're trying to put in, right? So my variables are perceived control, perceived stress, positive affect, negative affect, and life satisfaction. I noticed that we also want to keep a mind for APA here. If we go to our APA manual and look up what does a correlation table look like. So this is sample correlation table 710, and it looks like it's about page 215 in your book. And we're going towards this, that I ended up putting just the N in the note in the bottom, but we have mean and standard deviation. And notice how we don't need the top triangle because it repeats itself. We only need the bottom triangle. But I'm noticing that capitalization wise on these variables, just the first letter is capitalized. So I want to fix that on my table, that I just have the first letter capitalized, not the letter of the second word. There we go. So now it's kind of in the same order as what I'm running in my correlation matrix table in SPSS. So perceived control, perceived stress, positive affect, negative affect, and life sat. What I also want to ask for in the options area is means and standard deviations, because that's going to be part of that table, right? I want mean and standard deviation, and then the bottom triangle of correlations here. So we're good there, and I can paste, and here's my correlation matrix for the table. I'm asking for correlations just like before, but now I have more variables included. And the other difference is when this time I asked for means and standard deviations. So we have this line statistics descriptives. If I wanted to rerun one before with the descriptives in there, all I have to do is add it in. And then I could have those means and standard deviations in the first one that I ran. It would just run it again in my output. But here's my matrix table. We'll run this. And now we have all of this going on. So again, our top triangle is just repeated on the bottom. So 581, 581, 456, 456. So I'm only really worried about like half of this thing. And it looks like all of these correlations are significant at p less than 0.1. So when I'm looking at my table here, let me pull this in so I can see my output as well. There we go. I want to see all of those, so I'm going to arrange so that I can see what I'm doing over here in the Excel and the numbers over here. So you can do this different ways. There is a way to export the table here, and I would go to Excel. I would give it a name like Excel export and save and hit OK. And that would put that data into an Excel for me. So let me pick that up, Excel export. And it looks like this. So I can do editing to get this into this format. Sometimes I do that. It takes a bit of work. Like I have to unmerge everything, take off the shading, and do all kinds of I don't need this row for significance level. I don't need the in row. So it takes a bit of doing. Sometimes I'll do that, or sometimes I just copy the numbers over to my table, which is what I'll do this time. So I'm looking at my correlations table, and it's in the same order as what I have here, which makes it easier. So my relationship between total perceived stress and total perception of control is negative 581. Here, whenever you're leading with a negative, Excel thinks you want to like subtract something. So when you want the negative just to stay put, and it's not a function that you want to Excel to do, you want to lead with an apostrophe. So the single quote. If I lead with that, and now I have negative 0.58, and I'll round to 2 places. And I also want the double asterisk, so I'm going to put that on. So that negative and double asterisk, Excel's going to think that I want to compute something, but I don't. So the apostrophe or single quote mark in front of that tells Excel, hey, don't worry about it, it's just text. So now when I hit return, it just leaves it there. If I don't do that, it gives me a little error saying, hey, what do you want to compute? I'm like, I don't want to compute anything. So positive affect was 0.46 when I round. And you see how it put the 0 there? But I don't need a 0 when I'm talking correlations, because correlation doesn't go above 1 anyway. So I can do the same thing, put a little apostrophe so that it knows, don't worry about it, we don't need a 0 there. This is -48. And this one is 37. Okay, and then I need the next row, which is going to be -44, 67, and -49. And since this is a small table, it's not as much to just type in. If it was a very much larger table, I would probably just edit through that exported Excel. So here I have -29 and 42. And here we have -32. And I forgot to put the asterisks on all of those, so I need the asterisks. And speaking of the asterisks, down here in the note, because I don't have any p at less than 0.5, I don't need that particular information in the caption. It doesn't help anything for the reader because the only significant values we have is the double asterisk, which is less than 0.01, it says in the bottom of the table there. So we'll leave it like that. The other thing I want to say in the note is that my n was everywhere from 429 to 436. Oh, there's a 426. So my lowest n was 426. My highest n was 436. So I'm going to indicate that here in the note as well. Oops, I was typing in the wrong place. Okay, so there's my information. I am going to want that n italicized. There we go. And I still need the mean and the standard deviation, right? And that's not so hard. It's a little easier to work with. If I go to the descriptive statistics table here, I can just copy these numbers because they're all together, right? That makes it easier. So all I did was Control C or Command C to copy the means and standard deviations right out of the table there. I couldn't do that with this one because it's got all that extra information like the significance value and the n. But with mean and standard deviation, I can come over here and paste. Oh, gotta try that again. I'm gonna copy, come over here, paste, there it goes. And I'm gonna say just paste. I wanted just values, but it's not giving me that option, but that's okay, because right now it pasted it in Arial, and my table's in Calibri, So I'm going to have to change these to Calibri to keep it all the same. There we go. And I only need 2 places, but I'm going to copy it and go ahead and put it in here. That's another reason you want these in the same order in your output so that you don't have to sort them out over here in your table. And I'm going to copy and paste them into that area there. And I'm going to select those numbers and go up and tell Excel that it's a number, and that way it did the 2 places for me. So that's good. So I don't need this anymore. I'm going to delete that information. And here, typically what APA wants is centered. So they want all this information more or less centered. So I'm going to take that and hit the center button. Another thing I'll do is take the whole thing and make sure it's aligned to the top, just so that I don't have them being in different places when I try to cross this over to Word. So I think I have it all ready to go. I'm going to select from the very top corner of the table to the bottom corner, and I'm holding the Shift key to do that. And I'm going to Command or Control C to copy. And then I'll move over to where I'm trying to put this into my write-up. So I have all of my correlations here, and we did all that work putting it into Excel and getting the table into Word. I made a place for it where it's just got the table 1, and I'm pasting here. So Control V or Command V is paste. Okay, so here's the table. Right now it's too close to the margin on this side. So I'm going to select the table and go up here into the menu to Layout. And I'm looking for Auto Fit Window. Okay, that worked all right. Sometimes we have different things it does, like it puts these on different rows. Sometimes it's quite a fight, but I did most of the cleaning already in Excel so that it's not fighting me so much here. I don't need table 1 and table core, so I'm going to take off that, and I can go ahead and even delete that row. Everything else is looking okay so far. It kept my italics. Okay, so that one didn't fight me too bad. Usually they fight me a lot more. And then the figures, tables and figures go on their own pages. It usually starts with your appendix. Tables come before figures, and each one gets its own page. So here's the figure that I got about the histogram, and the other histogram, and the scatter plot. And let's look at getting figures out of output here. If I have a figure that I want, there's a couple ways I can do that. I can simply right-click and copy, and then go to my Word document and go down to wherever I'm going to put it. Like, let's say I wanted to do, I'm doing Command Enter or Command Control Enter to get a new page. And I could say figure 4. I'll need to fix the font on that and paste what I copied. That figure I just copied, I can just paste it like that. Another way you can get figures out of output is to right-click and export. And once I get my export window, I would want to adjust the type to graphics only. And then I can come down here to the graphics part and give it a name that makes sense, box plot. And it's going to save that as a PNG file. I have to do OK at the end to get it to do the actual export. And then it'll be in the folder I told it. So there's the box plot PNG. And that's if I want the figure separate from the Word document. Like maybe I want to use it in a different document, or I want to have it on hand in case I need it, but I don't need it in my Word document right now. So I can just have it as an image file, because as an image file I can even add anything to it. Like I can work with it to add any extra legend or anything like that before putting it into my Word document. So that's a couple ways that you can get images out of your output and get them ready for your write-up. Okay, let's take a look at this write-up. We have our information about how what the data set was about. We told the reader where table 1 is with the correlations, and told the reader how assumptions were evaluated. And we did a simple regression here to test the predictive ability of perceived control on someone's perceptions of stress. And we have our prediction equation, and we have the tables and figures that would be after your write-up. All right, we got a lot done here in our Lab 3. We did some assumption checks, specifically the univariate normality and bivariate linearity, which is normal first assumption checks you would do when you have variables that are continuous. We conducted a straight linear regression with one predictor, one outcome, and we did a full write-up of results of that linear regression. And we also created a correlation matrix to summarize those study variables for the reader. So that's it for Lab 3, and I'll see you in the next lab.